Fever is part of our immune system. It's part of our innate immune system, and it's one of the most common signs that our immune system is working. And the reason why it's a great thing that our body does is because it tells us that there is something wrong with our body. Usually it signals an infection, and it's actually helping with that infection. So a fever is when our body raises its baseline temperature above normal. So normal temperature is around 98.6 Fahrenheit or 37 degrees Celsius. But when someone has an infection with like viruses or bacteria or too much inflammation, your brain will reset the thermostat and try to make our whole body temperature higher. And that's when you feel cold or you start shivering before your temperature actually goes up. So your body is trying to match this set point in your brain. And so why does someone get fever? What causes fever? And the short answer is our immune system causes fever on purpose. And the key component of that's causing the fever are molecules that we call pyrogens. So the word pyrogen usually it means fire producer. So pyro means fire, and these are substances that signal that to your body to raise its temperature. And there's two types of pyrogens. There's exogenous pyrogens and there's endogenous pyrogens. Remember, these are what's signaling to your brain to raise the temperature. So exogenous means that the pyrogens come from outside our body. They're usually molecules from microbes like bacteria or viruses or fungal infections. One of the most important examples is something called lipopolysaccharide or LPS. This is a molecule that's found on the outer membrane of certain bacteria. And so this is good because when your body has this bacteria, your immune system detects these microbial components and says that this shouldn't be here, and that triggers a response to raise your temperature or to cause fever. There's also endogenous pyrogens. So endogenous means that they're made by our own body. These are cytokines. Cytokines are small proteins. They're signaling proteins, and they're released by our immune cells, especially in response to an infection. Some of the most important endogenous pyrogens are something called interleukin-1, IL-1, interleukin-6, IL-6. There's something called TNF-alpha, which is tumor necrosis factor alpha. Once our immune system cells detect infection or injury, they release these cytokines into our blood, and they will travel to our brain, specifically to a part in our brain called the hypothalamus, which is responsible for regulating our body temperature. So how does the brain respond to this whole thing? So when the hypothalamus receives these signals, it responds by producing a molecule called prostaglandin E2, which tells our brain to raise the baseline temperature. So this is when you start to feel cold, even if your temperature is already normal, because your brain now thinks you're too cold. So your body shivers to generate heat. It starts constraining blood flow to the skin to conserve heat, and it raises your muscle tone, all to increase your internal temperature. So eventually your body reaches this new set point, and that's when you have a fever. And fever is actually very helpful for a short period of time. Fever can sometimes feel uncomfortable, but it has a lot of real biological advantages. So some things that fever does, the reason your body does it is it slows down microbes. So many bacteria and viruses don't reproduce as efficiently at higher temperatures, and that's good because we want to contain an infection. We don't want it to spread. Fever also boosts our immune system response. So fever enhances the activity of certain white blood cells like neutrophils and T cells. Even molecules like interferons work better at slightly higher temperatures. And fever also reduces access to nutrients. So fever can reduce levels of iron and zinc in our blood, which a lot of microbes, a lot of pathogens need to grow. So fever isn't just a side effect, it's something that our body uses to fight off infection. But now too much much fever, fever for a long time can be harmful. Most of the time, fever is not dangerous, especially if it's mild to moderate and if it's only a few days. But there are situations where fever can be a concern. So very high fevers, like above 104 degrees Fahrenheit or 40 degrees Celsius, can be dangerous. And also in infants, we worry about fevers. Even low-grade fevers should be seen in babies. All fevers should be seen since their immune systems are still developing. There's something called febrile seizures that can happen in some children, and these are usually brief and they usually don't cause long-term harm. In people who are immunocompromised, meaning they have a weak immune system, even a mild fever may signal a serious infection. And finally, fevers that last for many days without a known cause should always be medically evaluated. You should check with your doctor. This is just a video explaining the biology of fevers. So should you treat a fever? And generally we would want to say not always. Treating a fever with medication like Tylenol or ibuprofen can make you feel better, but in some cases reducing the fever may also slow down your immune response. So the decision of whether to treat depends on the situation. If someone has a fever and they're generally a healthy person and it's just a few days, it's fine, especially if they're not in any discomfort. You should give pain medications when someone's fever is making them very uncomfortable or it's gone on for many days, but always check with your doctor. So to summarize, this fever is caused by pyrogens, which are molecules that signal our brain to raise body temperatures. Exogenous pyrogens come from microbes. Endogenous pyrogens are made by our immune system, like interleukin 1, interleukin 6, and others. And fever helps our body fight infection by slowing down pathogens, microbes, activating our immune cells, and enhancing cytokine activity. And it's usually safe, but too high, too long, or in certain people, it can be a concern.